this video, we are going to be touching upon the Solidity basics. We are going to be covering upon what exactly this language is, and with a lot of executions, how the code works, how the code compiles, and everything which you need to get started with this language, right? So this is the first video in the series of videos in which I will be covering upon the basics as well as implementations of every types in the Solidity. So yeah, I hope that you stay tuned with all those videos. So let's get started. Let's go to the slides second. So this slide means that's what exactly the Solidity is, right? So first thing first, the language itself is object-oriented language. When I say object-oriented, it means we can easily manipulate the code, and it is essentially used by a lot of languages like Java and the JavaScript. A lot of Ruby is also using this. Even C++ is also have the same model. And maybe if you may have heard of JavaScript, most of the thing in JavaScript is said to be an object, right? And I can easily manipulate a lot of code. It is very usable when you have a complex data, a complex code. So then this usability comes to the picture. Then we have the statically typed and high level language. So statically typed means if you look at Java or JavaScript is basically a dynamically typed language. So you can easily change the values once you declare them. But in this, you can't change that. They are statically typed. You can't change that. Once you declare, you can't change that. Then we have, it supports a lot of libraries and user-defined types. So libraries, you can import libraries on top of your code. And let's say if you maybe like React, in React, just go on the top, you just install the your, I would say, library with npm or maybe a yarn, and then just import the library on the top by using import command. Just the same as this React in this Solidity, it's basically you can just import a certain URL for your library. Let's say OpenZipling, its most popular library, which you can use. You can see me using a lot of time in the upcoming videos. You can import that on the top of your certain this code, and you can they also have user-defined types. A user can define a certain type of types, and this basically the same. Then we have easy learning curve. Maybe like easy learning curve. When I say easy learning curve, it's very much similar to Java and JavaScript, because everything in this in Solidity is it's really easy. You can easily touch upon the basics and maybe like intermediate concept of Solidity maybe in the week, right? And you can easily brush up the entire advanced stuff in a month, right? If you be consistent, if you learn on a daily basis, right? That's how easy it is if you are already familiar with a lot of other languages like Java or maybe like JavaScript. And last point is essentially it's very much influenced with Java, JavaScript, and C++, and it's also supports library and it's kind of all stuff. Now, the next slide which we have right now is how the code of Solidity is essentially run. So the code of Solidity is essentially run on a certain type of machine, which is also known as Ethereum virtual machine. Now, this set of machine, you can think of it like a bunch of computers who are, let's say, just built on top of Ethereum, and you can think of it like a lot of bunch of computers who are bunched together on this Ethereum network, right? That help us to execute the transaction, and these are the same. Then once we write a code, let's say we just write a code, let's say console.log. It's essentially the type of JavaScript. When we type a code in maybe like console.log, and then that code is essentially converted into a bytecode, and then that bytecode is going to be understandable by the machine. Then it shall show us the result on the console. That's how the basic code of this certain language continues to works, right? So that's how familiar with JVM, Java virtual machine. It's also the same. It's almost the same, right? But that works in a centralized manner, but this works in a decentralized manner. Cool. So next we have. So I just prepared this design for you. This is essentially a certain type of network. You can think of like an Ethereum network, and a lot of computers are connected to each other, and these are basically in decentralized manner. There are billions of computers who are connected in this Ethereum network. It's just a small example of how things kind of works, right? So this is a person who are requesting a certain transaction, and if he's requesting a certain transaction, he need to pay a certain type of gas fee. Now, these computers are decentralized, but they essentially run by miners who helps in processing a certain type of transactions, right? So to reward them, you need to pay an extra sort of gas fee that then distribute among the different sort of your miners and etc., right? Once you pay the transaction fee or maybe like gas fee, your transaction is approved, your transaction is executed by the miners, and then they return a response that your transaction is successful. If you pay higher gas fee, then your transaction would be fast, and yeah, your execution would be fast. Now this is the simplest concept. Now just move ahead. Now next thing, we have two components in the Solidity file. So when you compile your file, there are two things that are generated, right? The first thing is your bytecode, and second thing is essentially your contract ABI. So let's understand both of them one by one. Now the first thing first, we have bytecode. So bytecode is essentially it's non-human readable, but machine uses this to show the output of the code, right? So if you think of bytecode, bytes are certain type of function, like the 0, 0, 1, 0, 1, 0, 1. But in the case of Solidity, it uses hexadecimal values. Maybe the values goes to F, right? It may be like 0, 1, 2, 3, 4, and also includes maybe like letters to A, B, C, D, and all to F. That's the compilation of entire things done to show the output of the code, and it's used by the machines to then show us the output. And now if you look at this, I also show a certain type of example over here. If you are familiar with JVM, it's also used the same mechanism to do the same stuff for us. Now move ahead. So this is example of bytecode. Now bytecode is essentially, if you look at this, this is your EVM bytecode. Looks like this. There are a lot of hexadecimal values, as I already mentioned that. So you will see there is a binary code, and this is essentially the certain type of code which is written in the Solidity file. Then that compiles down to this certain type of Solidity code. This is the binary code or bytecode. So then let's move ahead. Now we have contract ABI. So the contract ABI means your application binary interface. Let's say we have a bytecode and we have an ABI. Then they both make connections to each other. Then the connection which is built by between them, then it shows the output of the code, and then the machine uses that to show us the certain type of output. This means that that defines a standard schemes to how to call functions in a smart contract and get data back. Methods and structures are used to interact with the binary contract, just like an API does with the lower level. And the main function, if you look at this, this is basically in JSON format. You can use ABI to make a structure to get the data for your certain type of contract. Let's say now, if you may have heard of contract is essentially a certain piece of let's say if I have a contract, everything which is written in a blockchain are termed as a smart contract, and basically this is in a JSON format. It returns at the inputs. We have an input of u into 56, a name. These are the data types which I will touch upon that in later the video.